systems and how computers use them. We will learn how computers represent and process numbers using different systems like binary and hexadecimal. Let's begin our journey into understanding how numbers work inside machines. Here is what we will learn in this chapter. First, the objectives, then the introduction to number system. We will look at how numbers are written using base B and how to represent them in polynomial form. Then we will study the main number systems. We'll learn how to convert between them and finally practice binary operations like addition, subtraction, multiplication, and division. By the end of this chapter, you should be able to describe the most common number systems, binary, octal, decimal, and hexadecimal. Understand why computers use the binary system, convert numbers from one system to another, create sample conversion table, and finally perform basic binary arithmetic. Today, computers are everywhere. To understand how they work, we must know how they process and represent data. There are many number systems used in digital technology, decimal, binary, octal, and hexadecimal. Since computers only understand 0 and 1, we will focus mainly on binary representation. So, what is number system? A number system is a method of writing and expressing numbers using digits or symbols. The number of digits or used depends on the base, written as B. Each base gives us a different way to count and calculate. The base tells us how many digits we can use. For example, the decimal system uses base 10 and has digits from 0 to 9. The octal system uses base 8 with digits from 0 to 7. We should always specify the base unless it's base 10, which is the default. In base B, a number is written using only digits allowed by the base. Each digit has a position and each position has a weight, a power of the base. We write number like this. The digit D0 is the least significant and Dn is the most significant. We can also write numbers in polynomial form using the base. This helps us understand the value of each digit. Here are some examples. There are many number systems, but we will study 4 main ones. Each has its own base and use in computing. First, the decimal system is the one we use every day. Its base is 10 and its digits are 0 to 9. If a number is written without a base, it is usually decimal. Then, the binary system is used by computers. Its base is 2 and its digits are only 0 and 1. Its digits is called a bit, short for binary digits. Example, 101 by 2 is a binary number. Third, the octal system uses base 8 with digits from 0 to 7. It was used in old computer systems like Unix. Example, 461 by 8 is an octal number. The last one is the hexadecimal system. Is used a lot in programming. It uses 16 symbols from 0 to 9 and from A to F. Example, 1F4 in hexadecimal number. This table shows a comparison between the 4 number systems, decimal, binary, octal, and hexadecimal. It helps you see how the same number looks in different systems. Now we learn conversion between bases. First, To convert a decimal number to another base, we use successive division. Divide the number by the new base, write down the remainder, and repeat until the result is 0. Then write the digits from bottom to top. Like this example, 30 by 2 is 1, 1, 1, 1, 0. Bottom to top. Then, to convert any base to decimal, we use polynomial form. Multiply each digit by the base power of its position, and then add them all together, like this example. Now, we understand the binary operation. First, the addition. Binary addition is simple. The rules are 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1 with the carry is 1. This is an example. 2. Subtraction. Now binary subtraction is similar to decimal. 0 minus 0 is 0. 0 minus 1 is 1. With 0 is 1. 1 minus 0 is 1. And 1 minus 1 is 0. Look at the example. Number 3, the multiplication. Binary multiplication is very easy. It's also like decimal multiplication. Just follow these rules. 0 by 0 is 0. 1 by 0 is 0. 1 by 1 is 1. You multiply bit by bit like in decimal. And this is 2 examples. Finally, the division. Binary division follows the same process as decimal division. We divide the bits and subtract step by step. It takes practice, but the logic is the same. Like these examples. To finish, let's summarize. In this chapter, we learned about the 4 main number systems: decimal, binary, octal, and hexadecimal. We studied how to converse between them and perform basic binary operations. In the next chapter, we will learn more about how computers represent data using different types. Thank you for watching, and once again, welcome to Machine Structure1. If you have any questions, don't hesitate to contact me by email or on the Moodle platform. You're welcome.